Welcome back to the class on HVDC transmission system. In this lecture, we are going to discuss about the Graetz converter with the overlap angle more than the last class we have discussed about the Graetz converter with the overlap angle less than the 60 degrees. When the overlap angle is increases more than the 60 degrees, then during the overlapping period, 4 devices are conducting. After the overlapping period, 3 devices are conducting. Why the 4 devices are conducting means when we are initiating the computation of the one device, the previous device computation is not completed. That's why the 4 devices are conducting during the overlapping period. Now we are going to see when exactly this overlapping is more than the 60 degrees. Suppose if any fault is occurs in the AC side, the AC voltage will be decreases, the current is more, then the inductance of a transformer is more, which increases the overlap angle more than the 60 degrees. This is the equivalent circuit of a Graetz converter during the overlap angle where the 4 devices are conducting. The T1, T2, T6 are conducting. Now we are giving a firing pass to the T3. So the 4 devices are conducting. When the omega t greater than the alpha and less than the alpha plus mu minus 60 degrees, if you apply the KVL in this loop and in this loop, we are getting the two equations. One is LC into di by dt, which is nothing but a voltage drop across this inductor, that is equal to EA equal to root 2 by 3 ELL sin omega t plus 150 degrees. Why this voltage is equal to this means the output voltage becomes a 0 when the 4 devices are connected. In the same manner, if you apply the KVL in this loop, LC into di2 by dt equal to minus EC equal to root 2 by 3 ELL cos omega t. Now we are going to find the expression for the I1 and the I6. If we solve this equation, we are getting the expression for the I1. I1 equal to IS1 sin of omega t plus 60 plus A. I6 equal to, I6 is nothing but the current which is passing through the 6 device. If you apply the KCL at this node, we are getting the I6 equal to ID minus I2. We know the expression for the I2 if we solve this equation. Now, I6 equal to ID minus IS1 sin omega t plus C, where IS1 equal to root 2 by 3 ELL omega LC equal to 2 by 3 IS. Now we have to find out the constant A and C. The constant A we can calculate from the initial conditions. Initial condition means omega t equal to alpha. When omega t equal to alpha, the I1 current, the current passing through the T1, that is equal to ID, that is equal to IS1 sin of omega t plus 60 equal to A. In place of omega t, you can take the alpha. Now we are applying the final boundary conditions for the equation. For this equation, we are getting the value for the C. The final boundary condition which is occurs at omega t equal to alpha plus mu minus 60 degrees, where I6 current is 0. So we are getting the ID minus IS1 sin of omega t plus mu plus 60 plus C equal to 0. If we solve these equations, this equation and this equation, we are getting the value for the A and C. These are the equations for I1, I2, I6 and the 4 devices are conducting. When 3 devices are conducting, that is happen when the omega t greater than the alpha plus mu minus 60 degrees and less than the alpha plus 60. In this case, how we are going to find out the I1 means again we apply the KVL where output voltage is not equal to 0. 2 LC di by dt equal to EA equal to minus root 2 ELL sin omega t. Already we got this expression when we are going to derive and 3 devices are conducting in a circuit where overlap angle less than the 60 degrees. And solve for the I1, we are getting the I1 equal to IS cos omega t plus B, where IS equal to root 2 ELL by 2 omega LC. LC is nothing but a source inductance. ELL is nothing but a RMS line voltage. Now constant B can be calculated from the continuity equation. See, this is the current which is passing through the I1, and the four devices conducting the I1 carrying some amount of current. We have an expression for the I1. The same manner, when three devices are conducting, I1 also conducting, it is carrying some amount of current. From the continuity equation, those two equations are equal. That we are making equal here. I1 omega t equal to alpha plus mu minus 60 degrees. At this boundary, Is dash. This is the equation what we got it previously in that place omega t. We substitute this one, we are getting the I1 Is1 sin alpha plus mu plus a equal to, in this equation substitute the this angle, we are getting the Is into cos of alpha plus mu minus 60 plus b. We have some symmetry between the I1 current and I6 current. So for that symmetry, I1 equal to I6 when omega t equal to alpha plus 60 degrees and omega t equal to alpha. How do we know the expression of the I1 here? In place of omega t, substitute the alpha plus 60. So we got the Is into cos of alpha plus 60 plus b equal to, we know the expression of the I6 previously. Id minus Is dash sin of alpha plus mu plus 6. If you solve all these equations, finally we got an expression for the ID, nothing but a DC linked current equal to Is 1 by 2 cos of alpha minus 30 degrees minus cos of alpha plus mu plus 30 degrees. But remember this equation, this is the equation for the DC linked current when the overlap angle is more than the 60 degrees. Equation, we are going to use this equation in the further explanation. DC output voltage. During the overlap angle, the output voltage is 0. After the overlap angle, only three devices are conducting, we are getting the output voltage. Vd equal to 3 by pi alpha plus mu minus 60 to alpha plus 60 degrees minus 3 by 2 EC d omega t. We know the expression for the EC. EC equal to minus Em cos omega t. Em equal to root 2 by 3 EL. Substitute all the values here, complete the integration and substitute the limits, and finally you are getting the expression Vd equal to 3 by pi 3 by 2 Em sin alpha plus 60 minus sin of alpha plus mu minus 60 degrees. Now here if you simplify this equation, we are getting the Vd equal to root 3 by pi Vd naught, where Vd naught is nothing but the output DC voltage without overlap angle into cos of alpha minus 30 minus sin of alpha plus mu plus 30 degrees. Just we change this one. We represent the same equation in terms of the cos. So just now we have derived this equation. By using this equation, if we simplify the voltage given by the converter with a overlap angle more than the 60 means, we are getting the Vd equal to Vd naught root 3 cos of alpha minus 30 degrees minus 3 Id by 2 Is. We know the value of Is. Substitute that value here and rearrange this equation. We are getting the root 3 Vd naught cos of alpha minus 30 minus 3 Rc into Id. This is the expression of the output voltage in case of a Graetz converter where the overlap angle is more than the 60 degrees. If we observe this equation means the overlap angle is less than the 60 degrees means here we can find only Rc. But if we overlap angle more than the 60 degrees, here 3 also added. Nothing but the resistance value which we are using to represent the effect of overlap angle is increased by 3 times if the overlap angle is more than 60 degrees. So ultimately the output voltage will be decreased very high when compared to the overlap angle less than the 60 degrees. This is the equivalent circuit of a Graetz converter with the overlap angle more than the 60 degrees. If the firing angle equal to 0 and mu equal to 60, the DC linked current is equal to Is by 2. Now we are going to analyze the DC output voltage and the voltage across the valves. To analyze this one, we have taken the firing angle 45 degrees and overlap angle is 75 degrees. The output voltage will be changing from positive to negative. Also, some duration zero voltage is there. Nothing but 4 devices are conducting here. The same here. Here, same. Here also same. If you observe the voltage across device, the voltage across the device also will be changing from negative to the positive. This is the high jump voltage. This is the low jump voltage. Nothing but 6 jumps we can observe if we observe the voltage across the device. Now the 3 jump voltage is equal. That is the first jump. That we can write it as Vj1 equal to root 3 by 2 ELL sine of alpha minus 30 degrees. The 3 jumps voltage are equal, magnitude is equal. So Vj2 equal to root 3 by 2 ELL sine of alpha plus mu plus 30 degrees. So in this manner, if the overlap angle is more than the 60 degrees, means the average output voltage given by converter is drastically decreases. You can find some zero voltage in output voltage. The same manner, the voltage across the valve also will be dividing into 2 segments. One is high jump voltage, another one is a low jump voltage. Nothing but the voltage is high jump is if it is across the device means high stress will be developed in the device. That we have to damp out by means of a damper circuit. Thank you very much for watching this video.